Well, thanks, Jeff. Hopefully everybody can hear me. Appreciate the opportunity to share with everybody a new program that we've been working over the course of the last year and a half, focused on bringing together critical maintenance tools to really stitch together the digital thread for the Air Force and others. So I'm going to talk a little bit about that today. It sure is nice to get together. It's been an interesting year for everybody, and it's nice to see everybody and see the interesting programs that people have been working. I appreciate the Air Force and everybody putting this conference on, even though all the crazy things that are going on. So appreciate everybody's hard work on that. So for this particular presentation, I'm going to go through a little background and the overall approach for the program. I'll talk about some of the key technology elements. System integration demonstration, I'll talk a little bit about some of that stuff we've been working recently. Talk about how this all kind of stitches together with the digital thread, and then moving forward, what we have left on the program. So this is a Rapid Innovation Fund program, and if you guys are familiar, I'm sure a lot of the audience has seen Chuck's presentation from a few years ago. I think Dallin shared some things on it earlier today, and you know, we've had a pretty significant push over the last handful of years to get to what we've been calling full credit for coal work holes. And there's a number of things that were set at our feet that we needed to address to get to that point. And we had some questions that we had to resolve. And I think people, if you've worked, structural integrity, you're working with, either NDI processes or coal work holes. These are the things that come up when people question, whether we can take greater credit for life improvement processes like coal working. So questions like, has each critical hole been cold expanded? How can you prove it? Was the work performed properly? Was it within specification? If you're completing NDI, was it accomplished? Do you know that there weren't cracks at those locations? Do you have a traceable thread for that engineered residual stress? All really important questions. And really this program is targeted at developing a new technology or new capability to go after and answer these particular questions. So this is a new Rapid Innovation Fund program. We have a great team, and really the focus is on creating that digital thread. It's been an important theme over the last handful of years. We're focused primarily on NDI and coal work technologies, not to say that it couldn't expand out beyond those, but those are obviously a pretty important focus for this program. Some key aspects of the approach is Inline and integrating with Inline to capture the digital thread. I know Uriah's got a presentation that's going to talk about Inline a little bit more, but it's a key aspect of this program. We also have to be able to track spatially where we're executing maintenance work. And so I'll talk a little bit about some spatial positioning technology that we've integrated in with the system. We've got a couple smart tools that we'll talk about. And then one of the other very important things is to make it easier and more effective for the maintainer. So we've built in some real-time feedback indicators for the maintenance personnel. We've made it a streamlined approach to capture data and ultimately automate the process of capturing the digital thread. We also are working on characterizing coal work process effectivity, and we team together with FTI on that, and it's a very important aspect of this program. Ultimately, the goal is to expand out to other technologies like blending or shot painting and take advantage of the new capability I'm going to talk about. So I mentioned team members. I have to really give them a lot of credit. I think everybody recognizes the A10 Program Office as being just a long-standing advocate for pushing the state-of-the-art and really trying to move the Air Force forward. They were the ones that put out this call, and they've been champions for us, and it's fantastic. We have a role understanding ASIP and coal working and residual stress and our expertise as it relates to that. We brought in some great partners with Edigent and their expertise in Inline and data collection and maintenance data technology. And then obviously fatigue technologies. You guys saw a presentation earlier on FTI's technologies and some of the things that they continue to work on. And so I'll talk about how we all work together as a team to develop the system that we're working on in this program. So from a very high level point of view, from an integration concept, you have to have a way to automate the capture of location compliance. Did I coal work the right location? Did I complete NDI at the right location? I have to automate the capture of the critical data, the digital thread that I'm trying to understand and prove to the ASIP community that, hey, the right work was accomplished at the right location. You have to have that integrated in an automated fashion with your maintenance data systems, so NCheck and Inline, and I'll talk about some of the improvements for that. And the feedback to the maintainer is also very important, so they know they've done all the work at the right locations and all of it passed the success criteria. But then ultimately, all this rolls up into aircraft structural integrity management, the digital thread, residual stress information, data-driven fleet management, optimized maintenance requirements. All of that is really what we're trying to accomplish with a system like this. So let's go through some of the elements of the new technology I'm talking about. So first and foremost, spatial tracking. There's definitely a lot of technologies out there. All of them have their strengths and weaknesses and trade-offs. Some of the key criteria we had, ease of use. It's got to be easy for the maintainer to use, minimal impact to their workflow. It's got to have the right level of accuracy. It's got to be transportable and expandable. Ultimately, we arrived on an iGPS technology. It's an off-the-shelf modular technology. It's scalable, so you can go from a local workstation all the way up to a full hangar and track spatially where you are in space. It's got definitely the level of accuracy and the precision that we need, and it's flexible enough to meet the requirements of the system. And it's scalable, and it's been proven for sure in similar applications. So that's our spatial tracking technology. We've got a couple smart tools that we developed and collectively worked with our team members in the program. I think some of you are probably familiar with the technology that FTI has been developing for their instrumented polar and their digital EX system. So this is their next generation polar. It's very important to move things forward from a co-work aspect for the industry, capturing data, the data stream coming off the polar, the pressure profiles that are applied to accomplish that co-working, and relating that to the effectiveness of the co-work process itself. So we integrate that digital EX technology that FTI has been developing with our spatial tracking technology, feedback indicators for the maintainer to ultimately track work was accomplished at the right location and have the data to determine whether it's in or out of specification. So ultimately, you've got a number of holes that you've cold worked. You have a good hole, you can kind of evaluate each event, and you have feedback to know, hey, this hole was out of spec, maybe the hole size was too large, maybe the wrong tooling was used. So we have that automated capture of data, the feedback loop, to know we can prove and answer those quality assurance questions that were put in front of us. We also want to relate that to residual stress, right? Because ultimately that's what's used for the analysis and lifing, like Dallin had talked about a few presentations ago. So we have to be able to stitch together, how do these pressure profiles relate to in spec and out of spec conditions? What does that residual stress look like? And then what should we use for managing the fleet moving forward? So that's all part of this program, trying to understand that linkage. FTI has done a ton of work, and then we're also doing some validation work in our program, looking at a number of different configurations and cold expanded holes, a wide array of materials and configurations to understand what's the response from the pressure for different configurations, to understand what's a nominal in-spec condition, what might be over expanded or under expanded, and have that decision tree capability in place so we can evaluate whether we have a good co-work process or not. NDI is the other key smart tool development that we have in this program. It's a little bit different focus. It's also very important to track spatially where inspections occurred. That's very important, right? But there's a lot of barriers in place right now to capture the NDI information in an automated fashion and get it into the management system so people can use that data. The NDI level 3s can use the information. They understand trends. They're going to have data that's coming off the Nortec equipment. And so we've integrated our spatial tracking technology with the Olympus Spitfire and the Olympus equipment. So no more sneaker net. That's a common phrase that you hear. No more sneaker net. An automated fashion that you can capture and understand the signals you're getting off of your NDI equipment and store that in Inline long term. So that's a key development also on the program. So there's been a number of advancements and improvements in the Inline and NCheck software on this program. You know, there's some big things incorporating positional and process affected data into the existing Inline data stream. You know, so we had to be able to physically see where you were on the NCheck screen while you were actually working on the piece of structure, and I'll show some videos of that here in a minute. We also have to be able to capture the process effectiveness, store that critical data and those trendables, and really capture the digital thread in an automated fashion and provide feedback to the maintainer also on the NCheck screen so they can kind of walk through the process steps. Some of the new features that have been developed, jobs and tasks. I think previously there were jobs, you have tasks. So you have a task for every single co-work location, every single NDI location. The engineers put this together ahead of time. You can have templates, so it makes it easy to automate the development of this. But you lay out the structure kind of like your work cards to where they've got a job, they've got the tasks, you know what inputs you have for the co-work process. For example, for each location, you know what material it is and hole size and all the inputs that are required to judge whether it's in or out of specification. And then as you go through and work each task, you can collect the data and you can have findings and results show up. But then we've also built in configurable rules. So for example, if you have a low peak polar pressure, it's going to throw a flag to say, hey, something was wrong with this location. It's not giving us a pass indication. Go look at it. Something was up. Maybe it's not a big deal. Maybe it is, but at least you have the indicators to know this was out of spec for one reason or another. So that's one of the capabilities that the Edigen team has built into the Inline and NCheck. Also, you've got to be able to track current tool position. So this is a screenshot of the new interface in NCheck where you have the physical model of the structure. You see this red dot shows you where you are from a current tool position. You've got results that are showing up and captured on the right hand side. So that's coming off the Olympus equipment, streaming real time over to NCheck so the maintainer can see the results, or the inspector. You can see where you are real time, you can see accomplishment of task, and you understand exactly what's going on. And then also rolling that up, Uriah is going to talk a little bit more about this, but rolling that up into the new prognostics capability in Inline really just empowers things. He's going to talk a little bit about some dashboard concepts and some prognostics capability. So when you add all those things together, you really have a powerful Inline and NCheck environment to use the data and leverage it to effectively manage your fleet. So those are some of the improvements in Inline and NCheck for the program. You've also got to be able to tie it all together. So this is one area where there's been a decent amount of development on this program. You know, some of these other technologies I've talked about are off the shelf or a little bit more mature, but we've got to have a way that we can physically and digitally connect all of these things together. Inline and NCheck are connected to the Air Force network, right? So you've got to get over the hurdle of connecting maintenance tools to the network. So we've been working through that quite a bit on this program, trying to make sure we have all those things in place. But we're developing, you know, the hub or the integration module that ties together your spatial tracking technology, your co-working tools, your NDI equipment, and it's adaptable for other smart tools, tying that in with NCheck and then ultimately Inline, so you have that full connection and integrated system where you can capture data. It's small and transportable, pretty easy to manage, and adaptable to add additional tools long term. So that gives you a feel for some of the key technology elements. That's things that we've been working on over the course of the last year. We're now really focused on the integration and demonstration phase of it and working some validation efforts. So I want to talk a little bit about that, and then I'll show a couple videos for some recent testing of the prototype system. So from an integration and validation point of view, it's really kind of a building block approach. We've worked through all the integration of all the elements, so everything is functioning together as a system. We've been focused a lot on exercising the full capability of the system, demonstrating capture of the digital thread for each critical process. You know, what data do you want to capture, to what fidelity level, and how do you store that off long term? And we're taking a building block approach. So we start from a basic coupon point of view. We'll have cracked coupons, or we'll have coupons for co-working, building up to a component level to where we have these adaptable configurations, where we can build up simulated aircraft structural configurations, all the way up to the A-10 full wing. So we've got a number of areas where we're testing the system and making sure things are functioning like they should be. So let's see if videos are going to work. It's always a wild question. So one of the things that you have to do is, if you're going to track things in space, you want them in relation to the aircraft coordinate system, right? And so the first process that's built into Inline, let's see if this is going to go. Wait for it, maybe. Oh, look at that, Josh, he's a superstar. So the first thing you need to do is you have to be able to track in aircraft coordinates. So built into NCheck, you'll set this up with the job and the tasks. You'll have certain reference points on your piece of structure. NCheck will walk you through the alignment process. You go touch off on those points. The system will calibrate and align, give you some feedback. And now, once you accept that, that tool is in aircraft coordinates, and you can see it on your NCheck model. So wherever he moves that probe, that's where that red point in NCheck, that's what you're looking at on the right hand, is NCheck and that real-time feedback of where you are in space. Now this happens to be one of the iGPS pieces of equipment. There's several others that we have. This is a little large, and I'll show some of the adaptations to some of the other equipment here in a minute. So that's how you align. You can align to an aircraft wing or your fuselage or whatever it might be as you're trying to set up and define your process. So one of the other things that we're working on is NDI and capturing the data and trying to give the inspector as much information as we can and as many tools as we can to make his job easier. So one of the things that we've been working on is being able to differentiate between multiple layers. So this coupon that Josh is working on here is actually the 9-hole standard that the Air Force has. It's got cracks and burrs and gouges, various damage. It's multiple layers. And so Josh is working through, he set up a job and tasks for each of these holes. You can see the NCheck screen walking him through. As he goes through and inspects each of the locations, there's a trigger that we've added in to the Spitfire. So when he's at the location, you can see the red indicator moving through the hole. That was a clean location. So he just said, yep, I just accomplished maintenance at that location or inspections. Now he's finding an indication right there, kind of in the middle interface. When he sees the indication on the Nortec screen, pulls the trigger, it automates sending that over to NCheck. You've got the screenshot, you've got the metadata for screen height and angle. You've got everything that you want stored off. The inspector can look at it, and then he can move on to the next task. So it's really kind of, in my mind, cool feedback for the NDI community, so that it makes their job easier. It captures all the data that us as an ASIP community want to capture, and it's a win-win. Make their job easier, no more sneakernet, and greater fidelity for inspections. So that's just a demonstration of some of the validation work we're doing for NDI. Go on to the next screen. This is a co-work example. So what we've done, we've got the A-10 wing again, and we have these adaptable coupons that we mounted up to these lower access holes. We've added those coupons into the model, and Josh is going to walk through and execute some co-work operations. So you can see he's got the instrumented polar. You can see our adaptation for spatial tracking. You can see the instrument move on the screen. He's now in the location, so it turns red, tells him he's at the right location. He's also got LED indicators on the equipment, telling him you're at the right location, you're getting good position data. So you can see now the information streams over. You have positional location, true faults, your pressure profiles, and everything that you want to understand if that co-work operation is in spec. And so he'll walk through. This is a job and task that he set up. We've got a number of holes here. I think for this particular coupon, they were all within specification. So this is some of the validation work we're doing right now. and we'll continue to work over the course of the rest of the year. But it's really kind of cool to see on your screen what's taking place, and then physically what's going on, on the aircraft structure, and being able to look at both of those at the same time, make sure you're at the right location, make sure you code work things correctly, and you've got that data stream that validates that you did everything correctly. So as a follow-on to the integration and validation work is our final system demonstration. That takes place early next year. Really, the goal is to demonstrate the full functionality of the system in an operational environment. So we're going to go on base at Hill. We're going to work directly with the Air Force maintenance personnel, where we're going to have a combined demonstration of both our team and their team using the equipment. And ultimately, we're going to go through, we built a bunch of demonstration cases for NDI and co-working, which includes both off aircraft, so those adaptable plates that I showed, and then obviously on aircraft on an actual A-10 center wing that we'll go through and do some demonstrations. Ultimately, at the end of this program, we have a production or a prototype system that's been demonstrated in an operational environment, or a TRL of 7. And really, the goal is to demonstrate the collection of digital thread, this final demonstration, all the way from start to finish. There's a lot of things that we're working from a digital thread point of view. I wanted to just kind of roll it up into a high level point of view and go back to those questions. So the questions were, was the maintenance event within acceptable limits? So we have our traditional FTI equipment, but now we've added additional capability with FTI's instrumented polar, the ability to relate that to residual stress, so we can answer the question on whether it's within acceptable limits. The other question is, was maintenance accomplished at the wrong location or at the right location? It doesn't do any good if you have good co-working if you didn't accomplish it on all the holes that were required. And so we've addressed that question too, and we have the traceable digital thread to prove it. And ultimately, all this leads up to that full credit analysis. Having things like SPARs and these quality assurance tools in place ultimately gets us down the path to establish the QA tools to support the path to full credit and take advantage of the benefit that we know is there. So what do we have left to accomplish? Well, we still have to complete system validation, testing, and final demonstration. As a follow-on to that, maturing the prototype system to reach TRL 8 and 9. Big focus, we need to get it production ready. Explore integration with other maintenance tools and technologies. We're already doing that. We've been working on a pencil scan tool. So for example, if you want to go up and scan something or touch something on the wing, a maintainer wants to know where things are in space, or he wants to outline some corrosion, so we've got a small pencil design that we're working on that he can just go up, scan it, and it will show up in Inline as a scan and an outline of the damage, right? So those are the types of things that we're already thinking about for other tools and technologies. Implementing the system for the Air Force, both at a depot and OEM application, moving forward. You've got different scenarios like new production versus maybe major modifications or SLEP programs, all the way down to just your standard depot inspections and repairs. Each of those scenarios, your system and your digital thread would be tailored to those applications, but you can think about how something like this would be beneficial for each of those. Ultimately, we're trying to answer the call to support those digital thread initiatives of the Air Force and others, and get the right quality assurance tools in place so that as the analyses mature and the other aspects mature to ultimately get to full credit, we've got the QA tools to prove out and meet that other leg of the stool. And with that, that's all I've got. Any questions?